Hello, guys. Good evening. This is Rahul from Network Journey.
Hello.
Can
Oh,
you all hear
good
me?
evening. Yes, we can.
Awesome.
Hello. Good evening, Rahul.
Okay. Hope you're all doing good today. So, just wanted to, give a brief introduction to what happened yesterday. So, we were having we were discussing some concepts about BGP. So, we were doing some labs, and also we also executed one of the labs using WAN interfaces and how to establish BGP neighborship within the autonomous system. So that was the thing that we did yesterday. And coming back to the lab, I have uh, I have my lab that you can see here. So this is one of the labs that I have, and also when you when you get enrolled to the network journey, I'll just show you the labs that we have in our environment. Okay, looks something like this. Let me go back to my screen. Okay, I think it's clearly visible to you guys. Do you want me to? Yeah.
Yes,
Okay.
sir.
Okay. As you can see here, this is the lab that Network Journey has created. Okay. So we have a kind of routers and switches connecting to each other. So yesterday we discussed concept of BGP. You can use this part for BGP configuration, BGP, IBGP configuration. You have around 5 routers here where you can actually configure BGP between them and also establish the IBGP and EBGP neighborship. And also there are some MPLS enabled labs also. There are some segments which actually take care of MPLS. And if you see here, there is a BGP here, external BGP, where you can make use of external BGP configurations. Here are some switching concepts where you can configure HSRP, which is nothing but the redundancy protocols. Okay, HSRP is just redundancy protocols, which you'll find in the switching part of it. And then you have OSPF. When you come to your dynamic routing protocols, we have our OSPF labs here. This is a segment which actually demonstrates the OSPF. You have different areas of OSPFs in our lab, which is already created for you. You just can go there, configure some labs for yourself and, practice them. And also we have some switches here, which is connecting to Cisco ASA, which is nothing but our firewall. The firewall is actually in placed outside the network, in the edge of the network. You can configure your OSPF and also check how does it behave with the firewall outside and what all the configurations that you need to do when there is a firewall around. You can see the different areas of OSPF being configured. This is OSPF area 23, OSPF area 40, area 0, which is the backbone area connecting to all other areas, OSPF area 75, and this is BGP, of course. And also there is some concept of redistribution, which is being held in this segment. So from BGP, from BGP, the routes are getting redistributed into OSPF. As you can see here, this is the ASBR, which is doing the redistribution. We can see the virtual link that is configured, OSPF virtual link that is configured. And once you go above, you can see the Ethernet DMVPN hub and spoke topology. And you can see the DMVPN hub and spoke here, which is using IPsec technology. So this is quite a bit of extremely helpful lab for us. So once you enroll, you can get get access to this entire vast lab, and you can practice that without any problems. And also these are pre-configured for you. You just have to, go ahead according to the lab that you need. You just can go ahead and configure them according to what segment you want. You just have to choose them and try to, practice them. So before we start off, let me actually I just wanted to initiate on few things. I just wanted to tell you a few things. So I also wanted to insist on the provisions that we as Network Journey give you. The provisions that we give are just writing it on a notepad, so that maybe you can write it down, or maybe you can go through it, take a screenshot of it. So we have a web portal access, which actually remains with you lifetime. Okay. Web portal access of Network Journey, which actually remains with you lifetime. And you have rack lab access, which has been given to you. As I told you yesterday also, we'll we'll be providing you with the provision of rack lab access, and you will be getting this for 6 months, in which you can, I think, 6 months is a huge time for you to practice all the labs. And then we also have workbooks, PPTs, PDFs, and all other stuff that will help you have the knowledge of CCNP Enterprise. Okay. Then coming back to the fourth one, we have, and also we provide you one more thing. So if you have, so some people will, they would wish to do the lab on their own. Okay. They do not want the, lab environment of the institution. They would like to go with the lab of their own. So for those kind of people, if you have good system configuration. Sorry. So if you have a good system configuration, we will actually help you to set your own labs. Okay, that is the fourth provision. So, but the mandatory thing is that you should have a good system configuration for that. So once you have that, you can reach out to any of us, and we can have the lab set up for you. And one more thing is we have 24/7 backend support. Okay, 24/7 backend support. So these are the provisions that I actually wanted to initiate it. I mean, insist on that yesterday as well. But yesterday we just started rapidly. So today I'm just you know keeping it here. You just wanted to, if you want to just write it down, you can write it down, and also you can look at the labs. Anyway, the call is being recorded, and also you will have the lab topology in front of you in the recordings as well. So just wanted to, give you a brief intro, and also the provisions to get you know about, I mean, let you know about the provisions that we are giving you. And also we have a not only this, we have a lab workbook as well. So as you can see, this is the lab topology and the workbook which is involved with the lab as well. Okay. As you can go through the workbook, we have as you can see, the lab one creates management interface, SSH, telnet. Second one configures trunk and VTP sessions. Then we work on the VTP version 3. So these are the labs workbooks that has been given to you, and also instructions given to you and how to manage the lab. So this again is actually working on VLAN management interface. Okay, so this is the workbook that will be sent out to you once you know once you go ahead and register yourself. So once we're done with once I'm done with the briefing you about the provisions that we have, let's go over to the topic. So yesterday, I just wanted to brief you about the things that we discussed yesterday. So yesterday, what we discussed is the basic BGP features. So what is BGP? What is an autonomous system? What are the BGP features? Okay, and what do you mean by autonomous systems? Does it say anything? And how does a protocol differ between two autonomous systems? What kind of protocol is used between two different autonomous systems? And what are the protocols used in the same autonomous system? We all discussed this yesterday. And apart from that, we also discussed about the the BGP neighborship. So we were actually creating the neighborship between the routers in the same autonomous system, that is known as IBGP. Okay. So when we say IBGP, you always have to remember that the BGP peering or BGP adjacency is done within the same autonomous system. So yesterday we were able to create, or we were able to do BGP peering successfully, and we did that with the help of using WAN interfaces. Now let me show you what are the how was it done. So this is the lab that we used yesterday, and using this WAN interface 1.1.1.1, 1.1.1.2, and similarly 2 in 2 dot network, 3 dot network, 4 dot network, we were able to you know create BGP peering, or we were able to establish the BGP neighborship using the WAN interface. Okay, this is the WAN interface. Okay, and we call this one connected to the internal network as a LAN interface. Okay, now what is the motto that we have today? So what is the thing that we are about to do today? So in the pipeline, what we've got is today we're actually doing the same neighborship, BGP neighborship. So we're actually going to work on the same BGP neighborship, but a small change is we are using loopback interfaces. Now, before we get on with the loopback interfaces, I just want to tell you the importance of loopback interfaces. Okay. What is the importance of loopback interface? Why do we use loopback interfaces? Okay. Now, anybody has any questions? Did anybody say something, or may I just carry on?
So what happen if physically connection disconnect and if
Mhm.
there is a loopback connection between two nodes?
That's right. If the physically something is disconnected, then there is nothing that connects you to a loopback interface. Okay, I'll just explain you the same thing. You can see that in my diagram. Okay, so we have two routers which are connecting to each other. We have established the neighborship with the WAN interface. Okay, so say that we have established our neighborship with the WAN interface. So once the WAN interface goes down, that is 1.1.2 goes down, then the entire neighbor is down. Okay. So if we connect through loopback interfaces, so let's say that I have done the BGP neighborship or peering through the loopback interfaces. What happens then? Is there any difference you're gonna see? So if you establish BGP neighborship or peering through the loopback interfaces, even though 1.1.1.2 goes down from this side, you have another way of reaching 12.0.0.1 because that is my loopback interfaces. So this is loopback 0, loopback 1, 2, 3. This similarly, this is loopback 0, loopback 1, loopback 2, loopback 3. So we're going to just use one particular loopback interface, 11.0.0.1/8. Maybe let's say this. Okay. So using this, if once we create a neighborship or BGP peering, the chances are that the loopback interfaces never goes down, loopbacks never go down. Okay, so that is one of the advantage. Second one is, if not through the direct interfaces, we can reach that particular loopback through the other way. Okay, through the other way. That's the reason why we mostly stress on the importance of loopback interfaces while creating BGP neighborship. And there are certain things that we need to keep in mind. There are certain things that we need to keep in mind while we establish loopback. While we establish neighborship using loopback interfaces. I'll tell you what it is. Let me take a screenshot of that. Now, when you create neighborship using the loopback, you have created a neighborship using the loopback. What is the loopback? I'll use 11.0.0.1 on router 1 and 12.0.0.1 on router 2. Okay, I'll use them to create the neighborship, but you should always have in the routing table of R1, it should know how to reach 12.0.0.1. Only then the neighborship will be up. Okay. In the routing table of R1, if it does not know how to reach 12.0.0.1, then the neighborship will not be up. So similarly, when you create a neighborship from R2 to R1, R2 in the sense I'm using a 12.0.0.1 as the loopback. From there, if I establish a neighborship to 11.0.0.1, R2 should have or should know how it reaches 11.network. It should have a route in the routing table. In the routing table, with so many entries, it should have an entry for 11.0.0.1. Only then it can set up or it can, establish a TCP session with that particular loopback. Okay, that is a very important thing that you have to keep in mind. BGP BGP peering using the using the loopback is important, is very important, and it has advantages also. But using a loopback for BGP peering should be handled with care. You should always make sure that your router has that particular route or that particular loopback interface in its routing table to ensure that the neighborship is formed. Okay, so we can get into the lab and try to experience that in our lab session. But before that, I would like to ask you guys if you have any questions till now.
What protocol are we running within this autonomous system?
We are using a IBGP between this autonomous system because it has the same autonomous system. We are actually using we are having the neighborship between the routers in the same autonomous system. So we are using BGP, but it is internal BGP. Okay, we haven't extended to we haven't even discussed the external BGP yet. We are just talking about internal BGP. Okay, does that clear your question?
Yeah, it's correct. I understand. So in that case, it means if R1 advertise a route to R4, R4 shouldn't forward it, isn't it?
That's right. It will never forward it to R3 or
so
it will, that's right. Yeah.
Okay. So why then if the connection between R1 and R2 fails, why will the route still get to R2 if the route should not be propagated through each route?
That's right. I will come to that. That's a pretty good question. So you're saying that. So the question is, I just want to make everyone understand the question that he's asking. So he says R1 will never forward. It will R1 will actually forward the 10.network to R4. Okay, that is fine. But if this fails, neighborship fails, this anyways, R4 anyways doesn't pass to R3. So how is it going to establish the neighborship? Okay, I'll just come to that. So we'll talk about the full mesh topology in a bit. So before that, I just wanted to, finish up with internal BGP peering using loopback interfaces. Okay. What we do usually, I'll just give a small hint on this one. So we actually peer in IBGP just because we have a split horizon rule. We have a split horizon rule, and we discussed about that. So since we have a split horizon rule, we know that the networks received from one BGP neighbor will not be passed on to the next one. So what we do, we actually pair or do a peering with all the neighbors inside the eBGP. So I will do a neighborship with 2.2 as well, with R4 as well, with R3 as well, and R2 as well. Okay. So if I don't have, if when I send 10.network, when I advertise this 10.network, so if this router is down or this 1.1, 1.1.2 is down, anyways, R3 will be able to see that network, right? R3 will be able to see that network, or R4 will be able to see that network. So once the loopback is up, so once we're able to reach this interface, even this will be able to see 10.network. Okay, so we'll just get back to that in a minute. We can show that in the lab as well. So I'll just demonstrate that in the lab as well. For now, I am just demonstrating. Hope this is actually magnified to you. Hope you can see that clearly rather than yesterday. Are you able to see the screen now clearly? Or is it
Yes.
very small? Okay, thank you for that. Okay. Now let me show you what I'm doing. So I have four routers. I'm configuring BGP, that is internal BGP between all of this. Okay. Now let's say show IP interface brief. Okay. When I do a show IP interface brief, I have all this pre-configured. I didn't want to configure on the class because it is time consuming and it takes a lot of time. So I just had it pre-configured. So you can see that all the interfaces are up. Okay. All the interfaces are up, and we can see that all the loopback interfaces are also configured. Okay. So we're good to configure BGP on this one. Similarly with other routers as well. When you do a show IP interface brief, I have all of them pre-configured with the IP interfaces. Okay, IP addresses. Show IP interface brief. Okay, we have everything up on all the routers. Show IP interface brief. Okay, so everything seems to be up. Let's go to router 1 and start the configuration. Now let's go to router 1. Let me maximize it for you, or take it this way so that you can compare and type in the commands. Okay, let's say configure a terminal on the router 1. On the router 1, let me initiate the BGP process. Router BGP 500. Let's say the autonomous system is 500. Okay. Once you initiate the command used to initiate the BGP process is router BGP 500. Okay. Now, in BGP, we discussed yesterday that the neighbor command is manual. The administrator himself has to give the neighbor command. So let's say neighbor 1.1.1.2. I'm sorry, we discussed actually neighborship with using the loopback interface. So let's say 12.0.0.1. Okay. And the remote AS will be 500. So I'm establishing neighborship with the loopback interface. Okay. And on the other side, so on one side, we have 12001 as my first neighbor. On the other end, my neighbor would be, any guesses? 14001, and remote AS will be 500. Okay. I have the two neighbor commands. Then I will say network 10.0.0.0 network. I will say no auto summary. Okay. So these are the networks that I advertise. I have given two neighbor commands. I have given the two, the network that I want to advertise. Okay. So this is about the router one configuration that I had to do. Okay. As you can see, there is nothing left to be advertised. One is 10.network in the LAN interface. One is the WAN interfaces. I have to advertise the WAN interfaces as well. Okay. I can advertise the WAN interface if I need. I'll say 1.0.0.0, and I'll say network 4.0.0.0. I can advertise the WAN interface. It's not a problem at all. We can advertise both the WAN interfaces. Okay. And I've done a neighborship with 12.0.0.1 and 14.0.0.1. So those are my neighbors. Now let's go to R2. I want to configure R2 in a similar way. Router PGP 500. Configure terminal router PGP 500. So the first neighbor will be 11.0.0.1. Is that right? Neighbor 11.0.0.1, remote AS 500. The second neighbor for R2. So this is R2. I'm configuring R2. The first neighbor is 11.0.0.1, and the second neighbor would be the loopback interface of R3, which is configured right next to that. It is
Yeah, it's
13.
0.0.0.1.
Yes, that's right. It is 13.0.0.1. Okay, so I'll say 13.0.0.1. So the neighbor command is done. Now I am advertising the network which is connected to me. So the network which
Sorry.
is connected,
Hello, this is 30 or 13?
13. The loopback interface, as I've written here, the loopbacks is 13. Okay. The
Thank you,
LAN
thank you.
interface is 30. Okay. Okay.
Yes, please go ahead.
Okay. Thank you. So I want to advertise my LAN interface, which is connected to this router, LAN interface going towards the LAN. So that is network 20.0.0.0. I want to advertise my WAN interface, which is actually connected on my WAN interface, which is one is 1.0 network. The other one is 2.0 network, isn't it? Okay, because 1.network is on the WAN interface here, and 2.network is on the WAN interface here. So I'll say no auto summary, no sync, and then I'll just write the command. I'll just save my configurations. Okay. Similarly, like if you just want to, reduce your configuration, I just wanted you guys to go through the configuration so that it'll remain in your memory. So I just was typing it. But if you find it, uh, you know, kind of boring, so we can do a show run BGP. You just copy this whole command into a notepad. Let's say I have copied this. Okay, this is R1. Just try to just trying to ease it up. Okay. Now let's go to R1 and R2 are done. So let's go to R3.
I
So
think I think you also need to change the host name as well.
which one?
Host
R3?
name instead of router, you need to type router 3, router 1, and host name like this.
On this one, you want me to change this? The R3 doesn't look good. host name?
Yeah, it's
No,
a
no, no.
simply here
In
is a
the
router.
control,
So that's why if you change the router 3, router 1, I mean
Ah,
host name,
uh-huh.
it will much easy to recognize the router.
Okay, all right. So if you want that to be there, let me change that for you. Configure terminal, host name, router 1. Oh, does that look good now?
Yes.
Okay. Okay, let's go to 3 dot network now. Let's discuss about the router 3 now. Let's see what it does. So on router 3, what are the configurations that I have to put in? Let me go to router 3 here. Okay. Now, as my friend told, let me change that host name to router 3. Router 3. Okay. Now, let's say router BGP 500. That is a common command to initiate BGP. So after that, I have to, you know, I have to declare my neighbors on router 3. So I'll say neighbor R2 is my neighbor. On R2, I'm selecting a loopback. So what is my loopback on R2? It will be 12.0.0.1. Okay, this is my neighbor on R2. Remote AS is 500. Remote AS is 500. Next, my neighbor is R4. What is that loopback that we are selecting? It is 14.0.0.1.
yeah.
Okay. Next, I am advertising the network which is connected to my WAN, which is connected to my LAN, which is 30.network, 30.0.0.0. Next, I'm connecting the directly connected interfaces, that is my WAN interfaces. One is 3.network, right? One is 3.network, which is on the WAN serial 1 bar 1, and 2.network, which is serial 1 bar 0. 2.network. Okay. Oh, which is network. Okay, 2.network. Okay. Okay, that is about the BGP configurations on this one, on the router 3. Let's go to router 4 now. On the router 4, we do the same thing. Configure terminal, host name, router 4, router 4, router BGP 500. Now I have to declare, it's time to declare my neighbors. My neighbor for router 4 is router 3 and router 1. Let me pick the loopback of router 1 first. That would be
That's zero
11.0.0.1.
dot one.
And I'll say remote AS 500.
Five.
Yes. And the second neighbor of mine will be on the router 3. I have to pick a loopback on the router 3, which would be 13.0.0.1. Remote AS is again 500. Okay. That looks good. Now it's time to advertise the networks which are connected to me. So I will say the network connected to me is 40.network on the LAN side. Okay, 40.0.0.0. Okay. Next, it is time to advertise the networks which are connected to me on the WAN side, network 4.0 and 3.0, right? Okay, so that gives the configuration. We're done with the BGP configuration. Now, whenever you go to each and every router, whenever you
No
go,
auto summary is left for router 4.
sure, we can do that also. That's a nice catch. Configure T, router BGP 500, no auto summary, no synchronization.
Oh, can I ask a short question?
Sure.
So what happens if you don't type no synchronization?
So that's actually our next topic. So we're
Okay,
gonna,
sorry.
yeah, no worries, no worries. It's you're always welcome to ask questions. Okay, so let's go to that router 4. Now let's look at the topology here. So when you look at the topology for router 1, I've given the neighbors as router 2 and router 4. What on router 2 is my neighbor? That is especially the loopback interface 12001. And what on router 4, especially the loopback interface 14001. Okay, so when I go to R1 and give a, let me save the configurations first, give a show IP BGP. Do you remember the command that we put in yesterday to check the neighbors? The neighbor table is always viewed by the command show IP BGP summary. Okay, I'm just going through again and again so that it just resides in your memory. Okay, show IP BGP summary is the command that actually helps you to, pull out the neighbor table. So when I do a show IP BGP summary, it gives me the neighbors. What are the neighbors? The neighbors are 12.0.0.1 and 14.0.0.1. 12.0.0.1 loopback of R2, 14.0.0.1 loopback of R4. Now, the problem is we're never seeing it up. The state is remaining inactive. We're not seeing the state coming up. So if the state is established, so BGP has various states for, you know, getting the router up or the state of neighborship up. We have several states. So if it says established, or if it says when it comes to the state here, nothing should be mentioned. You just have to see here the number of prefix advertised by this particular neighbor. Only then you can declare that the neighborship is up. If it says active, the neighborship is not up. Now, why the neighborship is not up? We actually mentioned it. We gave the command manually. We said, this is my neighbor. I gave in the correct address also. Nothing was wrong. Why is it not seeing 12001 as a neighbor? So first of all, whenever using loopback interfaces, my first I should be whatever you say in BGP. In BGP, the thing to be kept in mind is whenever you give a neighbor command to any particular IP address, when you say 12001 is my neighbor, first you have to make sure that is in your routing table or no. When you do a show IP route, there is no network. There is no 12.0.0.1 network at all. Also 14. Do you see any 14 network or 12 network in your routing table of that particular router? So this particular router does not know in its routing table, it does not have 12 network and 14 network. So obviously it will never know where to pass the packet or from which IP address. So if I don't know that IP address, how will I send a TCP session to that one to form neighborship, right? So I don't know this 12.0.0.1, so I cannot send this TCP packet for establishing neighborship, right? As simple as that. No TCP session at all because I don't know. It's not in my routing table. As simple as that. Now, is that the same case with everybody? Let's go ahead and see R2. Let's see R2. Does he have something? In R2, so again, to view the neighbor table, show IP, BGP summary. It'll show you the neighbor table. Again, they're all active. Why? Let me do a show IP route. Now, what do you get by doing show IP route? It's a routing table of that particular router. When you do a show IP BGP summary, it is a neighbor table. And when you do a show IP route, it's a routing table. So in that routing table of that particular router also, we don't see 11 network and 12 network. I mean, sorry, 11 network and 13 network. That's the reason why this particular router does not know where the TCP session should be heading to. It does not know where to send it, right? Okay, so what should be done to establish the neighborship? Simple. So I don't know this network. Simple. Router is saying, I don't know this 12, where it is. I don't know. And even this router is saying, I don't know where is 11. Simple thing to be done is I will configure OSPF or EIGRP. When I configure OSPF or EIGRP, or if I add a static route, this router will be aware where is. So in simple terms, let me write just to demonstrate to you. On the router 2, I will write, I'll go here, I'll say on the router 2, IP route eleven zero zero one 255 255 255 255 255 0 go to 1.1.1.1. In the sense, this command tells that it's just that adding a static route. This command says that if you want to go to 11.001, next hop, take the next hop 1.1.1.1, 1.1.1.1. And that router R1 checks the routing table. Do I first of all know 1.network? Yes, it is directly connected on serial 1 bar 0. If it is directly connected 1 bar 0, I'll send the TCP session here. Okay. And I'll ask for 11.001. Anyways, router 1 also has the route for 11.001. It will say, okay, just go to loopback 0. Okay. I can either do this by adding a IP route, by adding a static route. So this is known as this what I did now is known as static route. Static route. Okay. Instead of adding this manually, instead of administrators adding the routes manually on every router, we can just, go ahead and configure a dynamic routing protocol, which actually establishes neighborship by its own. I don't have to do anything. I just have to advertise the network, OSPF or EIGRP or RIP. These are the dynamic routing protocols. Configure them and you will be able to reach the loopback networks. Okay. So the challenge in creating BGP peers on a loopback interface is, what we learned is the loopback interfaces should be reachable to every neighbor. Okay. That is what we learned. Now let's see as our next part, let's configure some internal routing on these. Okay. Let's configure some internal routing on this one. Use a dynamic routing protocol, let's say OSPF or EIGRP or whatever. I'll go with OSPF. Okay. When I go with OSPF, or I can go with EIGRP as well. So either of the two, I'll go ahead and configure on them. I'll make sure all these networks are reachable. Then the loopback will also be reachable here. Let's see what happens. Okay. Till here, any doubts? All good. May I take that as no doubts?
I have a question, Rahul.
Uh-huh.
So
Okay.
even if we are running IGPM, even if we are running IBGP, we still
Okay.
need OSPF or EIGRP, right?
Exactly.
Okay. I thank you so much. I understand it now.
And
So we
and
can't we
let
can't just run IBGP only. There should be an
That's right.
internal routing protocol, dynamic routing
That's right.
protocol. Oh,
Let me
okay.
actually little bit change your sentence, alter your sentence. If you're using IBGP with loopbacks, okay? If you're using IBGP with loopbacks, you need IGP to be configured so that the loopbacks are reachable. Okay. Especially the problem comes with the loopbacks. But if you're using the WAN interface, the TCP packets can directly be sent through the WAN interface, right? In the last video, in the last lab, we saw that we were using directly, we were configuring neighbor 1.1.1.2, which is the WAN interface of router 2. And we were configuring neighbor as 4.4.4.1, which is the WAN interface of router 4. Okay. That time we didn't have any problem. We saw that the neighborship was established, right? This time we are using loopback interfaces, and the other routers or neighbors they do not know where is the loopback interface, where is it configured, they do not know. In such cases, we use IGPs, which is interior gateway protocols. Is that good? Are you good with that?
Yes, I understand the concept now. Thank you so
Okay,
much.
no worries. Okay, let's go ahead and configure. Uh-oh. Hmm. Let me go ahead and configure this IGP. So let me take IGP. Let me configure which network. Let me take OSPF. Okay. Configure terminal router OSPF 1. Let me take the process as 1. OSPF process as 1. I am in R2. Just remember the LAN interface is 20. One side WAN is one network, or let's say 1.1.1.2. The other side is 2.2.2.1. The loopbacks is loopback 0, 1, 2, 3. Okay. Let me actually put it on the site so that you can see it. Configuring router OSPF. Now I'll say network 1.1.1.2. Okay. 0, 0, 0, 255 in area 0. So this will be explained to you why the OSPF wildcard bits are used, why the network is given like that. When I take up the OSPF class, I can explain you why it is written as such. Okay. Now let's just configure the IGP. Now let's say 2.2.2.1. So if you're using OSPF, just remember that all of them should be in the same area. Otherwise, you will have inter-area routing issues as well. Okay. Area. And also you need to advertise, let's say 12.0.0.1. Okay. Network 12.0.0.1, and I'll say 0, 0, 0, 255 in area 0 again. Okay. For now, I will just advertise 12.0.0.1 because that's the only loopback interface we're worried about. Okay. I'll advertise that as well. Okay. This is the OSPF command that I have to advertise. Okay. Nothing else. Let's go back to area 1. Router 1. Okay. On router 1, stop. Let me go to router 1. Okay. Again, configure terminal router OSPF1. So just like how we said, router BGP 500, router OSPF initiates the other protocols. Okay. Like OSPF, if you say router OSPF, it initiates OSPF protocol. If you say EIGRP, it initiates EIGRP. Okay. I'll say router OSPF1. Now I'll say, if you're looking at R1, the first network that I'll advertise is 1.1.1.1. So basically, all the directly connected networks you have to advertise. Okay. Basically, all the directly connected networks. What are the connected networks to your R1? It is 1.1.1.1, 4.4.4.2, and the loopback interfaces. So I'm doing that. Why am I not advertising the 10 dot network? Because I have advertised that in BGP. So not to worry. Okay. So I'll say 0.0.0 255 in area 0. Okay. I'm putting everything in area 0. And now let's say, see, already there is a message from OSPF. The link is up, saying the link is up. Network 4.4.4.2. Okay. And 0.0.0 255 in area 0 again. All of them should be advertised in the area 0. Then advertise your loopback interface, which is 12.0, sorry, it should be 11.0.0.1, right? 11.0.0.1.
This is only one IP, not network, right? That one.
That's a one particular IP. What are that? I'm just advertising, as I told you, the directly connected networks. Okay. Whatever. So my loopback interface has 11.0.0.1. So I just advertise that. Okay. Simple. Just to make it simple to you guys. Okay. Now let's see. I've configured between these two. Okay. The dynamic routing protocol is configured between 1 and 2. Basically, I can check it now, but let me configure on all the routers just to make it, just to keep it in memory to you guys. Let's go to R3. R3, you can say configure terminal. Okay, enable configure terminal router OSPF1. And let's say network. What's the network connected to router 3? 2.2.2.2. 0, 0, 0, 255 area 0. And the next command, oh, come on, configure terminal router OSPF1 network. Next command is 3.3.3.1 0.0.0.255 area 0, and the loopback is network 13.0.0.1 0.0.0.255 area 0. Okay, so that's very simple. I have advertised 3.3.3.1, 2.2.2.2, and I have advertised the loopback of it. Of router 1, the loopback is 11 network. Of router 2, loopback is 12 network. Of router 3, 13 network. Or router 4, it is 14 network. As simple as that. Just wanted to keep it simple, so I just configured this. Okay. Now let's go to router 4. When you go to router 4, the configuration is similar. We'll say configure terminal. I think this will confuse you. I'll minimize this. Router 4, enable. Configure terminal. Oh shit. Sorry about that. That'll take time. So basically what happens is once we do the configurations, all the networks will be able to reach one another. Okay. Once they're able to reach one another, the BGP session will be easily, established because they're able to see one another. Okay. The TCP sessions can be established between the declared interfaces. Configure terminal router OSPF 1, router OSPF 1. Okay. And then we have to advertise the networks on R4 now. So it will be the network 3.3.3.2. Next network will be 4.4.4.1 because that's the directly connected one. And the next one will be the loopback. Loopback is nothing but 14.0.0.1. 14.0.0.1. Okay. Now, by doing this, let's see what we have. Okay. Let's go to R1. I'll just say, just build the command, build the configuration that is write memory. Now, before when we did a show IP route, we were not able to see on R1, 11 network and 12 network were not forming neighbors through BGP. And we went into routing table of R1 and we could see that there were no route for 12 network. Let's do a show IP route again. Show IP route again. And you can see that there is a route for 12 network. And it says it is via 1.1.1.2. Okay. So it is able to reach 12 network. Let me try to ping it. Ping 12.0.0.1. Okay. The success rate is so and so. Now let's check BGP neighbor. Now let's give a command to check the BGP neighbor table. Now what is the command to check the BGP neighbor table? It is show IP BGP summary. Yes, exactly. And when you see that, now it's still not active, but there is a route. Okay. You confirm that there is a show. When you do a show IP route, you confirm that there is a network for 12. You confirm that there is a route, but still the neighborship says I am active, I'm not established. Now, what could be the next reason? So one more thing to keep in mind while creating BGP neighborships using loopback interface is always whenever you establish, whenever you go to R1, okay, whenever you go to R1, okay, say you're in R1, when you say neighbor 12.0.0.1, always the router 1 assumes that I am sending a TCP packet over this WAN interface, that is 1.1.1.1. But on the router 2, you would have given a command neighbor 11.0.0.1. Router 2 is confused now because I am receiving the packets from the WAN interface 1.1.1.1. But on me, the neighbor command that is typed is 11.0.0.1. So I have to send the packets to 11.0.0.1, but I'm receiving TCP packet from 1.1.1.1. So it never forms neighborship. To get rid of this issue, always when you use a loopback, you always have to give the command update source loopback command. Okay. In BGP, whenever you are using loopbacks, whenever you're configuring or whenever you're establishing neighborship with use of loopbacks, you always have to say update source loopback 0. When you say update source loopback 0, the TCP sessions, the origination of TCP sessions will be through your loopback interfaces. Okay. Now let's give the command on both the routers, on all the routers actually, in fact. Now let's say configure a terminal router BGP 500 Okay. Update source. Okay. Let's say neighbor. Who is my neighbor? 12.0.0.1. Update source. Loopback 0. Okay. Establish a neighborship. This command, the meaning of this command is establish a neighborship with 12.0.0.1, but update my source as loopback 0. Update all the TCP packets should be sent through loopback 0. Now do the same thing with 14.0.0.1 as well. 14.0.0.1. Awesome. See, immediately you get a command neighbor 12 is up and neighbor 14 is up. Okay, that's the major thing which was missing. Let's go ahead and do the same thing on router 2. On router 2, whenever you get into router 2, say configure terminal, router BGP 500. When you give router BGP 500, now think about the neighbor that you have on R2. Your neighbor would be 11.0.0.1, right? That is the one that we configured. And 2.11.0.0.1 update source loopback 0. Same thing do with another, because you have two neighbors on router 2. You would again do it for 13.0.0.1 as well. Okay. So for both of them, you entered the loopback source as your loopback 0 as your source. Okay. Same thing with configure terminal, router BGP 500, neighbor for router 3. Who is my neighbor? Let's go to this topology so you can see it. For router 3, my neighbor would be sorry about that. Configure terminal, router BGP 500. So for my router 3, the neighbor is one is we are establishing neighborship with the use of loopback interfaces. So for 3, my directly connected neighbor is R4, and the R4 has loopback of 14.0.0.1. I will say update source loopback 0. Same thing, I have another neighbor which is R2 and its loopback interface is 12. So I'll say neighbor 12.0.0.1 update source loopback 0. We're done with router 3 now. Let's go to router 4. The last one left is router 4, configure terminal. Now keep thinking what are the neighbors we have for R4. We have neighbor 11.0.0.1 update source loopback 0, and we have 13.0.0.1. These two are my neighbors. Okay. Now let's get back to router 1. We were not able to see the relationship, that is BGP peering. Now let's do a show IP BGP summary for seeing the neighbor table. Now there you go. Okay. Now there is a different view that you can see here. So when you say state, for the state you don't have nothing. It seems like that, but you have it populated below. Okay. State 3 in the sense, state or prefix 3 in the sense it is receiving 3 networks from this 12. Okay. It is receiving 3 networks from this 12.0.0.1 neighbor. Is it 3 networks really? Yeah, let's check. What is the first network? 1 dot network, 2 dot network, and 20 dot network. These are the 3 networks it is receiving from R2. So that is what it means by saying 3. Similarly, it is receiving 3 networks from 14.0.0.1. Is that the case? Let's see. 40.network, 3.network, and 4.network. That is what we have advertised in BGP. So those are the networks that will be seen. So the neighborship is up. How can you guarantee that? Because I'm not seeing anything which says active here. It is established, and I also am receiving networks from R2 and R4. Now let's go to R2, router 2, show summary. Again, even this is receiving some networks. There is no active. Active is vanished. Show IP BGP summary. Okay. Active is vanished again. R4. Show IP BGP summary. Okay. I'll keep the configuration up. Okay. I'll just write into it the memories to save it. So make sure that whenever you have lab set up on your end or your computer, make sure that you save your configurations now and then. Okay. So this is about the lab that we saw. What we did mainly, let's brief it. Okay. Let's actually brief it. Problem was in the loopback interfaces. So before we actually did the WAN interfaces, we did the neighborship. We actually created a neighborship using BGP, IBGP, using the WAN interfaces. Now this time we decided, okay, let's create a neighborship which established a neighborship using the loopback interface of R1 and R2. So when it came to R1, I said, okay, R2, your loopback is 12.0.0.1. So let me give the command neighbor 12.0.0.1 remote AS 500. Similarly, to R4, I said neighbor 14.0.0.1 remote AS 500. So I gave the same command on router 1, 2, 3, 4. Okay. Seeing their neighbors, whichever their neighbors are. But the problem was they were not able to see the neighbors. The neighbors were not established, but they were in an active state. They were not established at all. So what we thought, okay, let me check if the 12.0.0.1 is not in the routing table. Maybe that's the reason why it is not able to send the TCP packet to that 12.0.0.1. We saw the routing table by giving a show IP route, and yes, we were right. That was not in the routing table. So to give the routes, to update the routes, what we did, we configured an IBGP between all the routers. When I configured an IBGP on all these routers, what happened? All these were able to see the networks which are attached to them. They were all able to see the networks which are directly connected to one another. Okay, this one was able to see the networks which was connected to this one was able to see this one. So they were able to see one another, each other networks. So they were able to reach each other. But one more thing is, while using loopbacks, I have to say update loopback 0. Otherwise, by default in BGP, the TCP packets will be sent through the WAN interface. I didn't know that, so I had to update loopback source command, and once I updated it, these two became neighbors with each other. Okay, and there were all neighborship with each other. All the 4 routers were neighbors of each other. Okay, that's what we experienced in this lab by creating a neighborship using loopback interface. Some routers require OSPF to be enabled on interface. Then only OSPF adjacency will come up. Is it because of the iOS version? It could be because of iOS version, Tom. That's about the BGP neighborship which we established today using the loopback interfaces. Guys, you have any questions, you can go ahead and shoot the questions to me. I just want to make sure that everybody understood this. So can you, in case you shut down the connection between R1, is anybody talking? Yes. Sorry, I'm not able to hear you. Can you?
So please, can you hear me?
I can hear you. Yeah.
Yeah. So assuming the connection between R1 and R2 fails, the direct connect, the serial interface, can you still ping R2?
Okay, let's take out this. Let's do one thing. Let's go to R2 or let's go to R1. Okay, I will get this serial interface 1 bar 0 as down. Okay, configure terminal interface serial 1 bar 0. Okay, shut. I will shut down. Neighborship will be down. Okay, serial 1 bar 0 is down now. What is serial 1 bar 0? This one on router 1. Let me check the router 1 now. Clear IP BGP process just to make it reinitiate the process. Okay. Show IP BGP summary. Okay. Let it come back up. Let's give it some time. See here, you don't see any change in the neighborship. It's still up. Reason being, even though 1.1.1.1 link is down, even though this link is down, even though this link has been down, it can reach 12.0.0.1 through this way, right? Let's actually verify that on this routing table itself. Okay. How do you verify that on the routing table? Now,
Show IP route.
exactly. Show IP route. How do you reach 12.network? Now it's going via 4.4.4.1. See here? So if I want to reach 12.0.0.1, I'm taking this way now. Before it was taking 1.1.1.2, you remember? It was going via 1.1.1.2. Now it is taking this way. Let's see the previous show IP route. Okay. So see the previous IP route. To reach the 12 network, R1 was having 1.1.1.2 as the next hop, which is R1 was seeing 1.1.1.2 as the next hop to reach 12.0.0.0.1 network. Is that right? Yes, to see 12.0.0.1, it was going via 1.1.1.2. But since I took 1.1.1.2 down, now to reach 12 network, it is going via 4.4.4.1. 4.4.4.1. Right? Does that answer your question?
So it means anytime we use the loopback, we have to run some form of interior gateway routing protocol so that.
Definitely.
Okay. Thank you.
And also, I would actually suggest you guys, so keep practicing the labs. So whatever it is, whenever you read anything, any stuff, whatever you read, just keep practicing the labs. So that actually gives you, a bit of hold on the concepts or on the knowledge that you have. The labs are the primary thing. It can always save you. So which is the interface that we took it down? Was it
Interface 0./1.
S1 bar 0?
One.
Okay,
Sorry.
S1/0. Okay, and I'll give a no shutdown on this one. No shutdown. Okay, I'll give a right configuration. So guys, I don't know if you can see your chat. Okay, I'll just put that on your notepad, on a notepad, so you all can see it. So this is for admission pricing and discount price for the next 2 days. You can contact us through these contact details. I will read that out once again for you, or I'll keep it on the screen for like 2 minutes so that you can write it down or you can make a note of it, whatever. So the email address would be info at networkjourney.com, which is networkjourney.com. And the number to be contacted is +91 973 952 1088. Okay. So you can use the WhatsApp link also. You can use the WhatsApp link also. And also at the same time, let me actually, you can see the benefits also, which I've written on the top. Okay. You can make use of it. You can actually anytime reach out to us for any help. You can reach out to us. So you'll have a, as I told you earlier as well, you would have a web portal access which remains for the lifetime. You have rack lab access for 6 months, and I will once again, maybe some people, they stepped in late. I just want to go over the lab for you again. So you can see the labs here, labs that I've opened here. So there are very huge labs which actually segments it. We have a segmentation in the lab also. You can use a part of it for BGP. So every lab is, you know, it is segmented properly in an organized manner. You have some labs for BGP. As you can see here, many devices with BGP. You have the labs for OSPF with different areas, and also the backbone area, which is nothing but your area 0. And if the OSPF is not connected to area 0 directly, how to make use of the virtual links. Even the virtual link configuration or the virtual link lab is set up. And also, if you need to know the redistribution concept, you have the redistributing routers here from BGP to OSPF, or from OSPF to BGP. We generally call them as ASBR, which is nothing but autonomous system border routers. So you have some switching labs, VLAN trunking labs. As you can see, the switching labs here, you can configure VTP protocols. You have VLAN, you can configure VLAN labs, and also DHCP labs, as you can see here. So these are the provisions that we have in our lab environment. So you can make use of this vast lab. As you can see, we have such a big topology here. Okay. You can make use of this vast lab, and if you don't know anything, we can actually help you in creating any lab that you need. At the same time, if you have a good configuration, we will also help you to set up the labs in your home environment, in your laptop as well, or in your systems as well. And also, we would provide 24/7 backend support. Okay. We would be providing you with the workbooks, PPTs, PDFs, and all the other materials that would actually help you in gaining the knowledge. We would have lab access 6 months, as I told you, and 24/7 backend support. That really means something. Okay. Just take a look at the topology and also the provisions. So if you just have any interest, you can go ahead and contact details are on the notepad here. You can write it down or make a note of it. And also, at the same time, I just want to ask you also. So at the time I'm sharing this on the screen, do you guys have any doubts or any issues with any labs that you have tried, or in any BGP concepts that you want to progress on? Are you guys especially into the BGP stream, or generally in a networking domain, telecommunication domain?
Rahul, I have a general question. Can I bring it up?
Yeah, sure. Go ahead.
So the NRC and Encore, they have different exam blueprint from Cisco.
Right.
So how do you incorporate all these labs, both NRC and Encore, in one lab that you have created? How do I know that this lab corresponds to NRC and this lab corresponds to, let's say, Encore?
That's right. So for that, we have a day-to-day plan as well. So you can see that So once we discuss any topic, so I actually okay, your question, I got your question. So how do you get to know that this lab is for this and this lab is for that? That will
Exactly.
be out there. Exactly. So we will be out there. So I'm the one who will be working with you. So we have many trainers as well who will be working with you to show it up to you. So which lab can be used for, which particular concept. And fear not, there are labs for every single concept. For every single concept, you have a lab out there, and that can help you. And also, people around who will be taking labs, once you'll be taking labs, they'll help you and make you understand which lab is used for which concept. Okay. Okay. Somebody is asking the price of the course as well. So, sure. They've already you can contact the details here. You can contact info@networkjourney.com, and also, contact on +919739521088. So apart from that, lab questions, do you guys have any other questions?
Rahul, thank you very much for your time. You've done well. Thank you so much. I have a last question. Could you please show us the lab again? The one we did today.
Sure, definitely. The one that we did today?
Yeah, exactly.
Yeah, this one?
Yes, exactly. So assuming R4 and R3 doesn't have loopback interfaces configured.
Okay.
So how would it be more easier for us to configure IBGP, sorry. Do we have to point to the directed connected networks?
No, that you can do as well. So on the previous lab, just like how we configured the IBGP using WAN interfaces, you can do it in a similar way. You can configure that IBGP neighborship in a similar way, but on a router, generally talking. So when a router is given to you, a loopback interface is a logical interface, and you can create it whenever you want. So when you have loopbacks connecting these two peers, you can obviously, when you have a router at home, you can configure a loopback interface on that router and configure IBGP between them, right? So the advantage, so yeah, I understood your question. Yes, but it can be, connected through the WAN interface. I agree. Okay. You can always establish BGP session, that is IBGP session, through a WAN interface directly from 2221 and 2222. But having a loopback interface is more advantage. Okay. Loopback interfaces give you the advantage. That's all I wanted to say actually on this one. Okay. You can actually establish neighborship with both WAN interface and loopback interface also. Does that answer your question?
Thank you so much.
No worries.
Rahul, I really appreciate it. Thank you very much for your time.
Thank you.
Yeah,
Hello.
Hello.
Yep.
In addition to the loopbacks interfaces.
Sorry?
I
Hello.
think
Yeah, go ahead. I mean, your voice is a bit low. Can you just speak out loud?
Yeah, I just want to ask one question. What is the benefit of using IBGP over IGP?
So the benefit of using IBGP over IGP. Okay.
Yeah.
Yes, exactly. So I'll just write it down here. Now, say that you have these 4 routers, okay? These 4 routers, and you have one more router here, okay? This is coming from a different autonomous system, say 600. Now, if I come here to this particular router, who will understand this router's language? Only the router running BGP will understand that router's language, right? Because it is again coming from eBGP. It is again a BGP protocol used because it is between 2 different autonomous systems. It is using BGP. So once any information comes here, the only person that can read is nothing but the router which is running BGP. So if you want to send that information to any other router, okay, how would you send it? Of course, you have to use BGP, because the information which is in BGP language, I cannot tell it to the router which is running OSPF, right? So always a IBGP neighborship is formed between the routers. IBGP
Okay.
neighbors is required. Okay. So
Okay.
IBGP has the routes which has IBGP has the administrative distance of 200, while interior gateway protocols have lesser than that. So in an autonomous system, if you have both IBGP and other routers, other protocols like OSPF and RIP, obviously your IGP will be considered rather than IBGP because it has lesser administrative distance. Okay.
Okay.
Thank you for the question.
Okay. One more question. You have created multiple loopbacks in single router, right? At a
That's right.
time, can we advertise all prefix in BGP?
Definitely. Yes, we can advertise as number of prefix that you wish to in BGP.
Like
So
you
yesterday,
just created 11.001 and
Mhm,
11.0.1.1 like that.
mhm.
I can we can advertise all these
all
loopback in the
this,
BGP, right?
all the loopbacks. Yes, we can advertise all the loopbacks. As many as you have, we can advertise all of them in BGP. The reason why I did not advertise all of them, because it is time consuming and we just have 90 minutes for the session, right? So I just did not, for time's sake, I did not advertise all of them. Okay.
Then what is the benefit of using means what is the benefit of advertising all loopbacks in the same IGP?
Not necessary. So this is just for the lab purpose. I'm using loopbacks. So when I have to demonstrate, so if I have to tell you people that on router 2, I am on router 2, to show you that I am receiving loopbacks from, or if I'm receiving networks from R4, I configured some loopback interfaces. That's it. Okay.
Okay.
Otherwise, only if there is necessary, you can configure a loopback. Otherwise, you need not configure a loopback. Okay.
Okay. Okay. You mean single loopback is enough, right?
Enough for establishing neighborship. Single loopback is
Yeah.
enough.
Yeah. Okay. Thank you.
Okay. No worries. So, what else, guys? So, do we have any other questions? Do we have any other? Do you want to see any? Do you have any questions about
Yes,
the?
can you hear me?
You know. Yeah, sure. I can hear you. Tell me.
Okay, I have a question.
Uh-huh.
Okay, please, what's the difference between BGP and EBGP?
IBGP and EBGP, you mean?
Not IBGP, no. BGP and EBGP.
So both are same. I mean, so see, just like, so there is nothing called as BGP. Okay, BGP and EBGP both are same. So there is a protocol named as BGP. Okay, there is a single protocol which is known as BGP. It is used in the internet. Okay, it is used to connect different autonomous systems, different organizations in the internet. For that, we use BGP. But this BGP protocol is of two types. One is external and internal. Internal is known as IBGP. External is known as exterior gateway protocol, exterior BGP, external BGP. Okay. In external BGP, we would be connecting two different autonomous system, that is 500 and 600. Okay. In IBGP, we would be connecting same routers in the same autonomous system within 500, autonomous system number 500. That's it. That's the only difference between EBGP and IBGP. Okay.
All right, thank you.
Thank you.
Hello.
Yep.
Hi.
Hi.
Does IBGP and EBGP have same AD?
No, the IBGP has the AD of 200 and EBGP has AD of 20. Okay, so in an organization, if you have 5 network, okay, this is a 5 dot network, 5.0.0.0 coming into this router, and this is passed to this router through IBGP. And there is one more router which is actually having same 5.5.5 network passing to this R1 about same 5 network. This is EBGP, this is IBGP, because it is in the same autonomous system number 500, but this has a different autonomous system because it is from a different organization. So this route will be more preferred because it is external BGP and has a lesser AD value. This route will be preferred rather than IBGP route. Okay,
Okay.
you got it?
Another question.
Okay.
Yeah.
Yeah.
Another question. Can we modify IBGP AD?
Definitely, we can actually modify the AD of the IBGP, but that's definitely not recommended because all the protocols have left it to their standard value. So it is usually not recommended to change any AD because it will actually create some reachability issues. Hence, we're not recommended to do that, but of course, there is an option to do that. Okay.
Okay. Just a last question. Can
Mhm.
can we run BGP without any IGP protocol?
Definitely. Oh, yes, definitely. We can run IBGP without any IGPs. Yes, when you use
Yeah,
a
without
WAN
OSPF,
links.
without RIP.
Yes, when you use the WAN link. So in our previous lab yesterday, we actually did a BGP peering using the WAN interface, and we did not use any IGP protocol. We actually connected routers together in BGP. We established neighborship, but we did not use any IGP protocols. We use IGP protocols only when we use loopback interfaces. For reachability issues, we use IGPs. Okay.
Sorry, come again. I didn't get your last sentence there. We only use
So
IGP when we
whenever
use
we
loopbacks,
use
is it?
yes, whenever we use loopback interfaces, whenever we use loopback interfaces to connect or to establish BGP sessions, only then we use OSPF, RIP, or any other dynamic routing protocols to get rid of the reachability issues. Okay,
Okay. Okay. Got it.
awesome.
Otherwise,
Good
we can
questions.
use
Thank you.
BGP only on the physical
Yes,
interface.
right, right. That's right.
Thank you.
Thank you. So, guys, today actually we are done with the free 2 sessions of webinar. So, thanks everyone for your time. And so, if there are, and I came up with nice, interesting questions as well. So, which was awesome. And hope I have discussed with you the concepts that you needed, and hope it will help you. And also please, let's join, so please enroll. And once you enroll, we can actually work together. It's not like me teaching you yesterday. I just told you that. It's not like I would be teaching you and you would be listening to that. If you know any concepts, we can discuss on that. We can together troubleshoot on that. If there is something new, we can work together and get that knowledge in us. So whenever you're interested, or whichever concept you're interested, we'll be ready to, and we'll be more than happy to help you. So the contact details are there on the screen. You can make a note of it. Anybody interested, join. We can have classes. We can discuss further with them about the classes and the timings. So if you have any feedback to me, you can go ahead and give it to me.
I got one
Rahul,
question.
thank you so much. You've done a lot.
Thank you so much.
I have one question.
Yeah, go ahead.
When is it better to use OSPF versus IBGP?
So BGP is used on an external, when you're actually communicating between two autonomous systems. Okay, when you are in the same network or when you are in the single organization, okay, you have to use OSPF or all the IGP protocols, any other OSPF, any other IGP protocols. When it is a different autonomous system or different organizations, Okay, when there are different organizations managed by different administrative entity, only then you got to use BGP. Okay.
Okay, thank you.
Sorry, just adding on to that question.
Uh-huh.
If we want to use BGP in the same organization, can we do
Okay.
that?
If you want what?
To use BGP in the same organization.
Yes, definitely. You can use the BGP in your same organization, and that type of BGP, that classification of BGP is called as IBGP, which is known as Internal Border Gateway Protocol.
Yeah, without any IGP, that is possible.
That's right.
Okay, thank
you. But can you also use OSPF inside of your own organization?
Definitely. Definitely, and you should be using it because so each router has its own networks connected. So as I showed you, each router has its own network connected. Some has 10 dot network, some has 11 dot network, some has 5 dot networks. To make these routers, okay, to make these routers understand what is connected to other routers, what is connected to other routers, we run dynamic routing protocols between them, so it understands this particular network is connected to that particular router. Okay, that is why we run different dynamic routing protocols. One of the dynamic routing protocols is OSPF, RIP, ISIS, EIGRP. We can we can and we have to run it within an organization when you have many routers. Okay. Hope that answers your question.
Yes, thank you.
Thank you. All right.
What is the advantage of using BGP
Sorry?
instead of IGP? What is?
Can you be a bit louder? Sorry. Sorry.
Sorry. Can you hear me now?
Yeah, I can hear you. If that could be a bit louder, it would be great.
Okay. What is one advantage of using BGP then over IGP in the same organization?
No, it is not. It is not the. It is not the. It is not that we have two options and we are using it. We just have one option. Okay, depending upon the scenario, we use different protocols. So once you're in a network which is internal. Okay, so this is your organization. Say that you have a company. Let's say your company is Microsoft. It is managed by single administrative entity and you have many routers here. Okay, of course you're using OSPF, EIGRP, OSPF, RIP. You're using EIGRP. Okay, you use any protocols that you need because it is internal to your organization. When you want to connect with different organization which is managed by different administrative entity, okay, then you use BGP. Okay, there is no advantage. There is no advantage of one over the other. It is just the scenario. Okay, so you're within your own organization, you have the same autonomous system number everywhere, so you can use interior gateway protocols like OSPF, RIP, EIGRP. But if you're connecting to different organization, connecting to the internet, okay, then you have to use BGP. Okay.
Okay. We have a hub and spoke
right
topology in our organization. So I was just wondering of using BGP without any IGP protocol.
That's right. You can use the WAN interfaces, this WAN interfaces, to
like
connect
to
all these without any usage of OSPF. Okay.
Yes,
you can use hub and spoke topology and BGP over this. Yes, you can do it.
Okay, thank you.
Thank you. Okay. Any more questions?
I have one other. How do we see the recording for this lecture?
It'll be sent over to you. So the our team will be going ahead and sending you this one on. Sending it to you over. So it is available on YouTube, and the link will be sent over to you. Okay.
All right, thank you.
No worries. All right then, guys. That's all I have from my end. Thank you so much for you all. To you all for your time.
Thank you.
Thank you, everyone. And for if
Appreciate
you
your time.
thank you so much. Have a
Yeah,
good one,
thank you for
everyone.
sharing your time with us today.
Thank you. Have a good one. Bye.